So for this problem, I need to find the inverse once again. Okay, switch the x's and y's. Let's go ahead and isolate that cube. I need to take the cube root of both sides. So we have a y plus 5. And we have a y equals the cube root of x plus 14 minus 5. The cube root function, like, I'm messing up there. X to the third is, its inverse is always going to look like f of negative 1 x equals the cube root of x. It's always going to have that. And so if you look at the problem, if you look at the original problem, or we can call it a vertex if we want, it's that center point, is going to be negative 5, negative 14. Okay, it's negative 5 and negative 14. Well, what's the inverse of that? Negative 14, negative 5. So if we have a function that always looks like this, or when I put that negative 5 and negative 14 in, it looks like, oh, I'm running out of space. When I pop that 5 in, it's going to remember switch the sign. And its inverse, let's put it in a different color. Its inverse is always going to look like y equals the cube root of x. Well, if we have this point, then we could just pop it into our h and k. We have a plus h and a plus k, or minus h and a plus k. And so we have a y equals the cube root of x. Remember, when that goes in, we have to change the sign, minus 5. Isn't that what we got? Isn't that exactly what we got? Well, you can think of it that way too. You don't actually have to solve it algebraically. Okay? Good job.